So my name is Javier. I'm a lead research scientist in Flower Labs, and I'm going to be giving this welcoming session for the hackathon. It will be, I promise you, brief, no more than 20 or 30 minutes, so you can spend the rest of your time working on your demos. So we are super excited to see that we got an amazing response for this hackathon. Over 200 participants said they will come, and I'm sure they will join at some point during these 8 hours. But we got a super long list of over 400 people interested in participating. Students from many universities, of course Stanford, but others around here, like San Jose State University. There were many people from that university, and others across the country. Also, folks from industry, like from the biggest companies around. So this might be also a good opportunity for some of you students to maybe get an internship or something, which is quite cool. The entire Flower Labs team is here. You can easily recognize us with yellow t-shirts, although I see some of us wearing only black t-shirts, but that's good enough also. And we wouldn't be here without the help of Kimberly and Professor Hae Young. They helped us set up this room and book everything so we could make this hackathon possible. So I think we should give them a round of applause. Next, let's go briefly through the agenda. This is also available in the hackathon website, which you can find in flower.ai. Now we have the welcome session, and there will be a brief keynote given by Daniel very soon. And then right after that, the hackathon officially starts. As you know, there are people here for different reasons. Some people want to win the amazing prizes we have that I will introduce later, but others are here to present some of the demos they have already been working on for a while, or maybe sharing some of their research. So there will be 2 sessions of lightning talks, one before lunch and one after lunch. There is lunch, which could be a nice opportunity for networking at 12:30. Later in the afternoon, poster sessions, and then a big block of just hacking until dinner. 6:30, very important, the judges will go table by table, and you will be presenting your demos, one or multiple demos if you have some. And then we will wrap it up at 7:30 with the award ceremony. We are, I think, super lucky to have some, I think, really sick prizes. Some of them very generously given by AMD to pretty decent GPUs. They are over there if you want to check them out. They are real. And we have also, I think, in my opinion, the best prize, which is a rack, Desk Pi rack of 8 Raspberry Pis. That's over there as well. That's the grand prize, in my opinion. And then there's also a smaller version, which is still pretty good. And for other prizes will be a Raspberry Pi 5, which is amazing as well. So let's talk about the different tracks. The tracks, these are loose tracks. You can focus on one, or you can focus on all of them. That's really entirely up to you. But let me present them briefly. The first track is a bit more guided. So if you don't want to think of, oh, what can I do, or what data can I use, we have already made that decision for you. So we have a virtual federation setup with 8 clinics, where each of them have a portion of a data set. And these data sets have been heterogeneously partitioned. So some virtual clinics have more images of retina scans, some others have more images of blood tumors, and so on. And the task is, we are going to give you a Flower app that already works. It's very simple. It has a small CNN model that learns how to classify different pathologies. Your task is to take that up to the next level with maybe a better model and learn better from the distributed data. Once you have that model, probably you want to put it into some kind of service. Maybe it's a website, maybe it's an iOS app. It's entirely up to you. And that will be the demo. So the demo is not just the model checkpoint. It's more what you do with the demo later. The other track is much more open-ended. So there are no limits. You can use a simulation engine in Flower, or you can use a deployment engine. You can use any data that you are familiar with, or maybe you're used during your research or your work. For example, you might want to use some molecular data, or maybe some robot data. I see some stickers from Le Robot there. We have some examples on how to use Flower with Le Robot as well. But in the here are some ideas. For example, you might want to look into vertical federated learning, which is a form of federated learning that is a bit less common, but provides some interesting use cases. There is a big challenge of automatic data harmonization. You can think of it like there are different banks or different hospitals that they have data from the same domain, but they have them in different formats. For example, there are two banks that have big CSV files. They might have the same information about their clients, but the names of the columns are different. So you cannot just learn from that distributed data so easily. Some preprocessing has to happen. So how can we automate this preprocessing? So researchers trying to train from all this distributed data can only focus on the machine learning side of things and not on the data cleanup side of things. In federations, there are, as you know, multiple nodes, each holding different amount of data. And this means that each of them contribute differently to the global model that has been trained. So how can we design networks or mechanisms that incentivize nodes to participate in this training? How do we reward these nodes? That's something else that you can maybe think about and propose a system using Flower. These are just some ideas. Of course, you can come up with your entirely own idea, and that's super cool. The final track is not so much about using Flower for training a model. It's more about making contributions to the Flower open source framework. We have provided a long list of contributions that we know some of our users have been requesting for a while, and some others that we think could be quite interesting to build. There is a list here. You can talk to us. A few members of the Flower team work on the core framework every single day. So raise your hand if you have some questions, and we will help you. All this information about the tracks, you can find them very briefly described on our blog post that you can find on flower.ai/blog. And at the end of that blog post, you'll have a link to a much longer post on Discuss, where all the information about the tracks, the different tracks and different ideas that I presented earlier are described in a bit more detail. And there is also a FAQ section. Going into some important stuff, the demos. We will start the demos at 6:30. In principle, the judges are going to go to every table, but if you don't want to present a demo, we will skip you, but that's cool. You will have 1 minute for now to present the demo, but depending on how many demos make it to the final part of the hackathon, we might increase how long the demos can be. We would love to see that all demos are open source, so other people in the Flower community or new members interested in decentralized AI can make use of them. And we will evaluate the demos following 4 criteria. How innovative the use case is, what's the impact of that use case, how effectively it made use of Flower, and how well it was presented to the judges. Because again, there is only 1 or maybe 2 minutes, so it's important that the information gets delivered well. And then we will wrap it up today with announcing the winners at 7:30, and the top 3 demos will have a chance to present as well. So that was the welcoming session. I will present a brief demo about how Flower works. But first, let's listen from Daniel. He's the co-creator of Flower, and he's going to tell us something really exciting.
All right, good morning. I know everyone is eager to get started to build, so I'll keep this super brief. I just want to say a few words on why should we actually care about decentralized AI and decentralization. There's different reasons for it. There's different motivations. It's interesting from a research perspective. It's interesting from an engineering perspective. So there's a lot of challenges in that for the engineers to dig into. But I want to zoom out a little bit and talk about the more broader impact of this. We are interested in decentralization, actually not for the decentralization's sake, but the reason we're interested in it is superintelligence. Superintelligence is probably the most exciting thing that will happen in all of our lifetimes. whether you're interested in superintelligence or not, it's something that will have a deep impact on probably all of our lives. And even if you're not interested in just working towards superintelligence itself, I think what we can probably all agree on in this room is that we are all interested in working on better AI systems, just building better AI systems, whether that's for healthcare, whether that's for other domains. This is something that we should all be striving towards because it can have just such a positive impact on all of our lives. And now the question is, what do we need for superintelligence? Superintelligence, or generally better AI systems, they need scale. Over the last 10-ish years, models have scaled from hundreds of millions of parameters to trillions. Compute has scaled from a handful of GPUs to hundreds of thousands of GPUs. And the data has scaled also massively, starting with ImageNet. Data has scaled to now just using all of the data that's available on the public web. And I want to zoom into that just a little bit. If we look at recent training runs like Llama 3 or DeepSeek R1, those were trained on 15 trillion tokens. So this is cutting-edge models that came out fairly recently, like R1, is 15 trillion tokens. Why are they both trained on 15 trillion tokens? There's quite a time difference between Llama 3 and DeepSeek R1. The reason for that is it's pretty much all of the high-quality English text that's available on the public web. Now, I want you all to take a guess how much more data is actually out there. This is all public data, high-quality public data on the web. How much more data is out there that is not public? And those of you who attended yesterday's Flower AI Day, they already know the answer. But just take a guess. Is it the same amount? Is it maybe 10x the amount? 10x would be huge, right? 150 trillion tokens would be huge. It's that much. It doesn't even fit on the screen. It's actually 2,000 trillion tokens of non-public data that is out there and that is currently mostly unused to build AI systems. And actually the 2,000 trillion tokens is a conservative estimate. There's a lot of other estimates that put the number even way higher than that. Now let's zoom out a little bit to see the full picture. If we take a look at the small dot on the left, that's the data that we use today. The big dot on the right, that is the data that is mostly unused. And this 133x increase difference, that difference represents a huge opportunity to scale the data side of things. Build better AI systems, whether that's towards superintelligence or whether that's towards just building better healthcare or finance or manufacturing models. It's a huge opportunity and it's pretty much untapped today. On the compute side, things are very similar actually. Everyone is talking about these clusters of hundreds of thousands of GPUs. If you take a cluster that has maybe 200,000 GPUs, like the initial build out of the xAI Colossus cluster, and if you compare that to the amount of compute that we ship in mobile devices, actually the amount of compute that Apple ships with iPhones in just a single year is roughly 10x that. The compute has a very different shape. It's not always all available. You can't just run it like a single cluster. But there's a huge untapped amount of compute out there that is currently not being used. And I think it's interesting. If we think back at the original slide, what do we need for better AI systems? We need more compute. We need more data to scale up the training. I think the opportunity here is just massive. The compute is there, the data is there, but it's currently not really being used. Now the question is, how do we do this? And the traditional way has always been build a bigger GPU cluster and then move more data into that GPU cluster. But in many cases, this just doesn't work. It doesn't work to move the data. A lot of data is sensitive, it's not public, so it can't be easily moved. Now there's a different approach called decentralized AI. And I think we all heard of this. This is why we're here today. Decentralized AI just allows you to keep the data where it is, keep the compute where it is, and then run the training in a decentralized way. You just move the model to where the data is, you train the model for a little while, you exchange the learnings, and eventually you end up with one model that has seen all the data, that has used all the compute, and that model has potentially can just leverage a lot more data, can leverage a lot more compute. Hence, you get a better model. Now, this is why we've built Flower. So Flower has, since we open sourced it, it has become the world's most popular decentralized AI framework. It allows you to do exactly that in a fairly simple way. You can just bring your existing pipeline, whether that's a PyTorch pipeline or whether you use something else for training. And Flower is trying to actually get out of your way, get into the background, and allow you to easily decentralize the training of that. So Flower steps into the background. It allows you to bring all the tools you know and love. It allows you to build very different approaches on top of it. So it's pretty much agnostic towards the toolkit you use and towards the kind of model you want to train. You can train a small neural network. You can train a big LLM. You can also train other models, like maybe just a simple linear regression. Flower has a huge community. It's a global community. It's worldwide. If you want to support the project, you can give it a star on GitHub. And you can join the public Slack channel and get in touch with the community. So today, I want to welcome you all to the Flower community. Have fun during the hackathon, and let's get started.
Okay, we are almost done with a welcome. I just want to do a quick 5-minute demo about how to use Flower. I think this could be useful if you haven't used Flower before. So let's get into it. So actually, I want to start with something like Daniel said, bringing existing projects into Flower and make it federated or distributed is super easy. What I have here is a, whoops, no, I don't want this. What I have here is a very, very simple vanilla single script to do the training of a CNN on Cypher 10. So the most probably boring example of machine learning today, but this is how many of us started, unless you are super, super young. But yes, you can see that the training loop is very simple. It loads the data set, it creates some data loaders. Sorry, make it bigger. It instantiates the model, sends it to device, and then I want to do training for a number of epochs and also evaluating on the validation set or the test set. And the way these functions look, well, for this case is pretty simple. You define a criterion to define the loss. You have your optimizer and learning rate, and then you just create the batches and you do forward and backward pass through your PyTorch model. And for tests, you do exactly the same, but you don't backpropagate. And these Python scripts work fairly well. They are centralized and they use all the data. But let's say that we wanted to create something like this that allow us to start playing with federated learning using Flower. So we have built some CLI commands that allow you to start right away. We call it Flower New in this case, and I'm going to create a new app called my awesome app. It will ask me for just a couple of things. For example, what's my username? I'll write my name. My name is Javier. And then it will prompt me for what type of project I want to build. As Daniel said, Flower is framework agnostic. So these are just some simple projects using different machine learning or data science frameworks that get you ready to do something interesting. So I'm going to choose PyTorch. And if you were paying a lot of attention, you will see that a new directory appeared here. And this is the structure of my Flower app. It's a fully contained project. It has a PyProject.toml specifying some dependencies. In this case, as you would expect, torch and torch vision. There is a section as well for hyperparameters, things relevant to the learning, like learning rate, number of epochs, and so on. And critically, there are two files. One is the client app, which is the code, the part of the logic that runs where the data is. So this would be the training loops. For example, if I inspect what the training loop looks like, it looks exactly as what you would use in a centralized setup, because each client in isolation, its own is like a centralized training, but using up only the data it has, right? So you can use all the tools you are familiar with. In this case, I'm using image classification, but if you want to federate the pre-training of an LLM, well, what your client app would do is all the machinery to train the LLM. Or if you are doing fine-tuning, or if you are doing JAX, MLX, LL robot, you would use the same APIs you are familiar with. What Flower does is that it makes it super easy to federate that model. So in this case, once the model has been trained, I can put it into an abstraction that we call a Flower message, and that gets communicated to a server that will aggregate all the messages, in this case, all the models. And now we have a single model that has trained, that is the average of all the models trained in a distributed setup. If I want to run this, I can just follow the instructions shown here. For example, I will go cd my awesome app. I have already installed the dependencies, so I don't need to do it again. And I can just use the command flower run to start. By default, it's using some very simple algorithms to do this aggregation. In this case, it's called fed average, which, as you would probably imagine, it does the average. In this case, the weighted average of different models based on how many training examples each client provided. And we can see that after 3 rounds, the loss of my model starts going down slightly. So this is cool. It's a simple project, but it's a good starting point to do something more sophisticated. What I want to show you is that while this runs in simulation, I can also run it in deployment very easily without having to change anything but one thing, which is pointing to a superlink, which is like a server that is the entry point to a federation. And this superlink is in the cloud. I'll need to copy my IP address. You can copy too. There is nothing interesting there. And this superlink is where all these Raspberry Pis I have here, they are connected to. So when I do Flower Run, and in this case, I'm going to choose a remote federation that is called a remote federation. Now what has happened is all my code, all my Flower app, which is all this project here, has been bundled, and there is a code delivery mechanism built in Flower that all my clients that have data are going to execute. So my clients there, each of those Raspberry Pis is executing the client app and training locally on their data, exactly using the code I developed here. So this is, I think, one of the most powerful things on Flower. And if we let it run, it will do the thing. So I can show you. Here I have SSH into each of the Raspberry Pis. We can see that the process has already started. So this is what I wanted to show you in this 5-minute demo. Build all the Flower apps, no matter how complex they are, they look the same, they have the same structure. So I invite you to take a look at all the examples we have in our repository as a source of inspirations for the demos you might want to build during this hackathon. So now going back to the slides, final remarks. You are welcome to stay here during all the 8 hours, but I think it's a pretty nice day and the campus is quite cool here. So you are also welcome to work outside, maybe go to a cafe and then come back if you want. Very important is that demos will start at 6:30. So if you want to win something, be here at 6:30 for the demo. There are many examples, tutorials, and documentations in Flower. I think it's quite comprehensive, but feel free to ask a question to any of us if you feel stuck or if there are some errors that you cannot solve on your own. As you know, there will be some talks and opportunities for networking. So yeah, the talks will happen here. So I hope that's cool with everyone. And then the final thing, be kind to everyone. Here, I think people come for different reasons. Some people are super mega experts in hackathons. Others are maybe the first time. So if they ask for help, just be kind to everyone. And that's it. So let's begin. One final thing, feel free to join Slack. We'll be giving some announcements there. That's the QR code for the Flower Slack. And there is a channel called Stanford Hackathon 2025. So be sure to join them. If you want to get all the information I presented today, it's in our Discuss. So thank you very much for